Welcome back to Stack Lessons. Today's mission, turn Checkpoint 2, Security and Compliance Retrieval Challenge from a memorized fact into a decision you can defend. By the end of this video, you'll have stress-tested your recall on the 5 security and compliance scenarios that surface most often on the Cloud Practitioner exam. No new material today, just 5 short scenarios. A pause to think, then the answer. Treat this as a confidence check. If these patterns feel automatic by the end, you're ready for the technology domain. Over the last 7 episodes, you covered the entire security and compliance domain, the shared responsibility model in episode 7, IAM users, groups, roles, and policies in episode 8, the security services matrix, GuardDuty, inspector, Macie, detective, and security hub, in episode 11, network security with Shield, WAF, security groups, and network ACLs in episode 12, and the compliance trio, artifact, audit manager, and config in episode 14. Today's checkpoint pulls one scenario from each thread. Same format as the last checkpoint. I'll lay out the scenario, you pause and think, and then we eliminate the wrong answers one at a time until only the right one is left standing. Speed matters here. You have about a minute and 20 seconds per scenario, and the candidates who pass aren't reasoning from first principles, they're recognizing patterns they've already drilled. Security and compliance is consistently one of the heaviest domains on this exam, and here's the thing candidates consistently report. The questions themselves aren't conceptually hard. What trips people up is the framing. You know what a role does, but when the stem says something like, quote, a serverless function requires programmatic access to a key value store, you have to recognize that as service-to-service access in under 30 seconds. That recognition speed is the actual skill. Today, we drill it. Here are the 5 patterns we're drilling today. Scenario 1 is the patching boundary, managed versus self-managed. Scenario 2 is service-to-service access, the IAM construct question. Scenario 3 is finding sensitive data inside S3. Scenario 4 is blocking a specific IP at the subnet boundary. And Scenario 5 is the audit report split, artifact versus audit manager. 5 scenarios, 5 distinct keyword cues. Let's start. Scenario 1. A team is running 2 databases on Amazon Web Services. Database A is Amazon RDS for MySQL, the fully managed option. Database B is MySQL that the team installed themselves on an EC2 instance. The question is simple. For each of these 2 databases, who is responsible for patching the database engine itself? Pause here if you want to commit to an answer. Let's eliminate. Any answer that says Amazon Web Services patches both is wrong. The moment you install software yourself on EC2, you own everything above the hypervisor. Any answer that says the customer patches both is also wrong, because that's exactly the operational burden that choosing RDS removes. And any answer calling engine patching a shared control is mixing up categories. Patching the engine binaries is a clean handoff, not a joint responsibility. That leaves one option standing. The answer. On RDS, Amazon Web Services patches the underlying operating system and the database engine. On self-managed MySQL running on EC2, the customer patches both the guest OS and the engine, and on both databases, the data itself, the IAM permissions, the encryption settings, and the network configuration always stay with the customer. The keyword Q, the word managed, shifts engine patching to Amazon Web Services. The phrase on EC2 shifts it back to you. Scenario 2. A Lambda function needs to read items from a DynamoDB table. Which IAM construct grants that function the permission it needs? Your 4 options are an IAM user, an IAM group, an IAM role, or an IAM policy on its own. Pause and pick one. Eliminate the user first. Users are long-lived identities with static access keys meant for people or external applications. never for an Amazon Web Services service. Eliminate the group next. Groups are just containers that bundle users together. They can't be assumed by anything and they hold no credentials. Eliminate the policy alone. A policy is just a JSON document. It has to attach to an identity to do anything. That leaves the role. The answer is an IAM role, specifically, a Lambda execution role. When the function is invoked, Lambda automatically assumes that role and receives temporary credentials from STS. The decision rule for the rest of the exam: anytime an Amazon Web Services service needs to call another Amazon Web Services service, the construct is a role, not a user, not access keys, a role. Straight from the Lambda Developer Guide, a Lambda function's execution role is an IAM role that grants the function permission to access Amazon Web Services services and resources, and Lambda automatically assumes that role when the function is invoked. That's the official wording. When you see it on the exam, the keyword execution role is the queue. Scenario 3. A security team needs to find personally identifiable information sitting in S3 buckets across every account in the organization. On top of that, they also want to know which buckets are unencrypted or publicly accessible. Which Amazon Web Services service does both of these jobs? Pause and decide. Eliminate GuardDuty. It's a threat detector. It watches API calls and network logs. It doesn't read the contents of your objects. Eliminate Inspector. It scans compute workloads like EC2, ECR images, and Lambda functions for known vulnerabilities, not S3 buckets for sensitive data. Eliminate Cloud Trail. It logs who did what, not what's inside the files. That leaves the only service in the matrix that actually reads inside S3 objects. The answer is Amazon Macie. Macie uses machine learning and managed data identifiers to discover and classify sensitive data, PII, credit card numbers, Amazon Web Services access keys, inside S3. And the same service alerts you when buckets are unencrypted or publicly accessible. 2 jobs, 1 service. The keyword queue is the combination of S3 and sensitive data. That pair always points to Macie. And Amazon Web Services says it plainly on the Macie features page. Amazon Macie generates alerts when it detects publicly accessible buckets, unencrypted buckets, or buckets shared with an Amazon Web Services account outside of your organization. So even when the scenario only mentions unencrypted buckets and not PII, Macie is still the answer. Scenario 4. A specific IP address is hammering instances in a VPC subnet. You need to block that one IP at the subnet boundary so every instance in the subnet is protected at once. Your 3 options are a security group, a network ACL, or Amazon Web Services WAF. Pause and pick the one that actually does the job. Start by eliminating the security group. Security groups are allow only. There is literally no deny rule type. You cannot block an IP with a construct that can only invite traffic in. Next, eliminate WAF. It inspects HTTP requests at layer 7, and it attaches to application endpoints like CloudFront, Application Load Balancer, and API Gateway. None of those sit at a VPC subnet boundary. That leaves the one VPC control with explicit deny rules, which is the network ACL. The answer is the network ACL. It's stateless, it lives at the subnet boundary, and it's the only native VPC firewall that supports both allow and deny rules. The keyword queue. Any scenario that asks you to block a specific IP or CIDR range is always a network ACL question, because security groups physically can't deny. And Amazon Web Services settles it in the Distributed Denial of Service, or DDoS, Resiliency Best Practices White Paper. The guidance is straightforward. Security groups can only allow traffic, they have no deny rules. To deny specific traffic, You need network ACL rules. That's the principle behind every block this IP question on the exam. Scenario 5. An auditor asks for the System and Organization Controls 2, SOC2, Type 2 report covering Amazon Web Services infrastructure. On the same engagement, the customer also needs to start collecting evidence for their own SOC2 controls. So there are two distinct asks here. One about Amazon Web Services compliance posture, and one about the customers. Which two services cover them? Pause and answer. Eliminate Trusted Advisor. It runs best practice checks on your account. It doesn't hand you Amazon Web Services' third-party audit reports. Eliminate Config on its own. It records resource configuration over time and flags drift, but it doesn't map that evidence to a compliance framework. And eliminate using Artifact for both sides. Artifact only delivers Amazon Web Services reports. It doesn't collect evidence about your own controls. One important heads up before the answer. Amazon Web Services Audit Manager closed to new customers on April 30, 2026, and is in maintenance mode. For exam purposes, the service mapping still holds, but in a brand new account today, Amazon Web Services recommends conformance packs in Amazon Web Services config as the successor. The answer is two services. Amazon Web Services Artifact for the auditor's request. That's the self-service portal where you download Amazon Web Services SOC2 Type 2 report. And Amazon Web Services Audit Manager for the customer's own side. It continuously collects evidence from CloudTrail, Config, and Security Hub and maps it to the pre-built SOC2 framework. One real-world caveat: Audit Manager closed to new customers on April 30, 2026 and is now in maintenance mode. Exam questions still map this scenario to Audit Manager, but if you're building a new account today, Amazon Web Services directs you to conformance packs in Amazon Web Services config instead. Artifact is Amazon Web Services homework. Audit Manager helps you do yours. All 5 patterns in one frame. The word managed or RDS means Amazon Web Services patches the operating system and the engine. Self-managed or on EC2 means the customer patches everything above the hypervisor. Service calls service means an IAM role, PII. Sensitive data, or unencrypted buckets in S3 means Macie. Block a specific IP at the subnet means a network ACL. Downloading Amazon Web Services SOC report means Artifact. Collecting evidence for your own audit maps to Audit Manager on the exam, but note the asterisk. Audit Manager entered maintenance mode on April 30, 2026, and is closed to new customers, so in a brand new account Amazon Web Services directs you to conformance packs in Amazon Web Services config instead. Screenshot this if you want it for your final review. 5 things to lock in before we move on. Managed service means Amazon Web Services patches the engine. Self-managed means you do. When one Amazon Web Services service calls another, the answer is a role. Macie is the only service that classifies what's inside S3 objects. Only network ACLs can deny. Security groups physically can't block traffic. And Artifact delivers Amazon Web Services' audit reports, while Audit Manager helps you build your own, though heads up, Audit Manager closed to new customers in April 2026 and is in maintenance mode, so new accounts use conformance packs in Amazon Web Services config instead. Now let's see how well that landed with a quick 5-scenario quiz. Question 1. A startup migrates its on-premises MySQL database to Amazon RDS for MySQL. Under the shared responsibility model, who becomes responsible for applying database engine patches after the migration? Option A. The customer, because they still own the data inside the database. Option B. Amazon Web Services, because RDS is a managed service that handles OS and engine patching. Option C. The responsibility is shared equally between Amazon Web Services and the customer. Or Option D. The customer, but only after enabling Systems Manager Patch Manager. Pause here if you want more time. This one is B. The whole point of choosing RDS over running MySQL yourself on EC2 is to hand the operating system and the engine patching to Amazon Web Services. The customer still owns the data, the IAM permissions, the encryption settings, and the network rules, but not the engine binaries. Patch Manager is for EC2, not RDS. Question 2. A developer is writing a Lambda function that needs to write items to an Amazon DynamoDB table. What is the Amazon Web Services recommended way to grant the function the required permissions? A. Attach an IAM execution role to the Lambda function with a least privilege policy granting DynamoDB write actions. B. Add the Lambda function to an IAM group that has DynamoDB write permissions. C. Create an IAM user, generate access keys, and store them as Lambda environment variables. Or D. Attach an IAM policy directly to the DynamoDB table, allowing any Lambda function to write to it. Lock in your answer before I give it away. The right call here is A. Lambda assumes an execution role at invoke time and gets temporary credentials from STS. That's the entire pattern for service-to-service access. Static access keys in environment variables are the canonical wrong answer. Groups can't be assumed by services, and a wide-open resource policy on the table violates least privilege. Question 3. A compliance team needs to identify which Amazon S3 buckets across their Amazon Web Services organization contain personally identifiable information, and which buckets are unencrypted or publicly accessible. Which service is purpose-built for this? A. Amazon GuardDuty, B. Amazon Inspector, C. Amazon Macie, or D. Amazon Web Services CloudTrail. Run the decision rule from earlier before you answer. If you said C, well done. Macie is the only service in the security matrix that actually reads the contents of S3 objects, and it doubles as the bucket posture checker for unencrypted or public buckets. GuardDuty watches for threats, Inspector scans EC2 and Lambda for known software vulnerabilities, and CloudTrail logs API calls. None of them open the objects. Question 4. A security engineer needs to block a specific malicious IP address from reaching any EC2 instance in a VPC subnet. Which Amazon Web Services control can enforce this at the subnet boundary? A. A security group with an inbound deny rule for the IP. B. Amazon Web Services WAF attached to the VPC subnet. C. Amazon Web Services Shield Standard, which automatically blocks malicious IPs. Or D. A network ACL with an explicit deny rule for the IP. Think about which constraint matters most here. It has to be D, and here's why. Security groups are allow only. Option A describes a rule type that doesn't exist in Amazon Web Services. WAF is a Layer 7 control that attaches to CloudFront, ALB, API Gateway, or AppSync, never to a subnet. Shield Standard handles volumetric Layer 3 and 4 DDoS, not single IP blocks. Only network ACLs combine subnet scope with explicit deny. Question 5. Let's test a concept from an earlier episode. An EC2 instance running an application needs to read objects from an Amazon S3 bucket. According to Amazon Web Services best practices, how should the application authenticate to S3? A. Embed an IAM user's access keys in the application code. B. Attach an instance profile that wraps an IAM role granting S3 read access. C. Use the Amazon Web Services account root user's credentials, stored in an environment variable. Or D. Create an IAM group with S3 permissions and add the instance to the group. Got your pick? Let's see. The answer is B. EC2 gets temporary credentials through an instance profile, which is just a container that wraps an IAM role and lets the instance receive short-lived credentials from STS via the metadata service. Embedded long-lived keys are a well-known security anti-pattern. Root credentials should never be used by an application, and groups are containers for users, not instances. Service-to-service access is always a role. That's it for today. Checkpoint 2. Security and Compliance Retrieval Challenge is one of those lessons that quietly upgrades how you design systems. Let it marinate. See you next time.